Well, I hope you can all hear me. My name is Gavin White. I'm a structural engineer from Cambridge in England. It's great to be here, to be able to speak to you and give you some of my experiences from the UK and the market that we've got over there. I should say that I'm a structural engineer. I do design in timber, but I also design in steel and concrete. And I think that actually gives me a kind of a unique perspective on this. We're trying to advise our clients on what's the best material to use. But I end up advising them quite often that timber is the right material, and I probably spend about 50% of my working life working with timber. So when you think of the UK, you might think of, I know, the red buses, the Houses of Parliament. You might even think of this guy, Austin Powers, but that's not me. But you probably don't think of this, which is cross-laminated timber. Whilst we don't have production facilities in the UK, we do use a lot of it. Probably about 10 to 15% of the output from Europe comes into the UK. And this is a project that we did, the Open Academy, probably about 8 years ago, where we finished this one. So I've been working with cross-laminated timber for about 12 years now. I've completed about 40 cross-laminated timber buildings in that time. So, and in the UK, there's probably about 600 or something buildings. So it's been quite a journey, and I think of those 12 years, you're probably at about the year 2 stage, I've seen from what I can tell, relative to where we were. So I think you'll actually accelerate beyond where we are and do it faster. But it was quite interesting to get there. So in the UK, this is the graph that we've kind of looked at in terms of the production and the use of CLT in the UK. So as you can see, it's gone up pretty steadily since about 2011. And we've actually completed in the UK, not just us, but all the other sort of suppliers and everything else, about 125 football pitches. So that's about 10 million square foot of internal area of buildings that have completed. So a lot of internal area that we've completed in cross-laminated timber. So I think most of you know what cross-laminated timber is, but obviously it's put together in softwood layers and put orthogonally to each other. And in the UK, we get it transported across. So it's about 13.5 meters long by about 2.95 meters wide. So I put the US measurements in there. So that's what we get transported to the UK. So that's what we try and work with when we're doing the design. And typically it comes anywhere from about 50 millimeters thick to about 300 millimeters thick. To be honest, I've only ever used the 300 twice, I think, in my whole career. I think we try and stick to between about 100 and 200 millimeters thick for most of our panels. And I thought it'd be useful just to put this up. This is obviously where all the various production facilities are around the world. A lot of them concentrated in Europe, and obviously a few based over here. So, I think from my perspective, it's quite interesting to see how you can get that production facility up here and get that market really going for it. So when we get our panels and when we design them, they turn up on the back of a lorry much like this, and they'll get lifted into place. So it's a very simple technology. I know people are trying to talk about it being quite a complicated technology and things. I actually think cross-laminated timber is actually a very simple technology, and I'll come on to some of the connections and things later. And it's applying the knowledge we have just in a different way. And I think that's really important for me and what I try and get across to our clients when we talk to them. So I suppose one of the questions I might ask is what's stopping you from using cross-laminated timber? Well, we've also already heard about the production side, but from my perspective as an engineer, what's stopped me from using it in the past? Well, these are some of the queries that we come up with against, with the clients and the contractors and the architects and things. It catches on fire. There aren't enough, the supply chain is not developed enough. That might be a one for here, but there's not enough architectural freedom. It costs too much. These are the things that we've always come up against, and we always try and. Over the years, we've learned how to batter these back. And to be honest, I haven't been stumped by any of these in the last 5 years. We've got answers to them, and we've been through them. We've talked to people through it. So we've definitely found that the benefits definitely outweigh the negatives of this of producing and building with cross-laminated timber. So some of the advantages that we've seen, and certainly as engineers, and what we've seen our clients really grasp is, and I'll take you through some of them now. One of them is it's a fast program. So cross-laminated timber, we find that the projects that we do are about 10 to 15% quicker if you're building them in cross-laminated timber as opposed to potentially a steel or a concrete frame. So that's really important. But you might think, okay, well, what about what about the weather? You know, surely that can impact it. And wind does, but you know, in the UK it does rain. Probably not quite as much as it does here. And I did take a quick look at this. I looked at London, I looked at the rainfall, and I looked at the temperature. And then I actually looked at what it was like here in Portland, because I thought it'd be a good comparison. And it's a lot wetter here. It's a lot wetter. But you know, the temperature-wise, it does get a bit colder as well. But to be honest, we have rain in the UK, and we get over that. And certainly on the site visits yesterday, it was quite interesting to see how some of the parties have got over that, certainly with the nail laminated timber. So I thought that was quite interesting. And you know, it does snow in the UK very occasionally. And you can still actually put the CLT up in the snow. In fact, one of the projects we were working on, they had to stop all the concrete works because it was too cold, but they carried on with the CLT. So you know, that just put it in perspective for me about how there's lots of advantages to the CLT side of things. With that 10 to 15% saving on program comes a saving in cost in terms of the overall project. Yes, cross-laminated timber does cost more in the UK than a steel or concrete frame. It's probably about 20% more as a pure frame solution. But when you take into account that program saving, it actually comes out cost neutral or even better. And we're certainly seeing now, before, say, 5 years ago, it really was just about cost neutral. Now it's coming out actually cheaper, and people are choosing to use CLT as a production material because of the cost effectiveness of it. Another thing that we've noticed is the construction waste. Obviously, it's all prefabricated off-site, and that really reduces the construction waste. On the Open Academy slide that I put up earlier, that only had 2 skips of construction waste during the whole superstructure erection. So it was really great for the environment in that respect, and also had much less people on site, so there's much less risk of accidents and health and safety-wise, so it's much better for that perspective. Airtightness, I haven't really heard this talked about much, but we find that with the cross-laminated timber, our buildings are 50% better airtightness than a steel or concrete frame. I think that's a really important thing for me, especially when you think about the environment and everything. If you can have a nice airtight building and you can manage that, you don't have to put as much heat into the building. You don't have to have as big HVAC equipment. So you can suddenly, there's other savings in there that need to be taken into account that people don't really appreciate. And you know, that's what I really wanted to get across to you today is these kind of other savings that we're still only scratching the surface of in the UK. And if you can really embrace those and get people to do it, then you can start to try and address some of the cost efficiencies of CLT. Foundations, well, CLT is a lighter weight material. It's probably about, we've looked at it, and it's about 30% lighter than an equivalent steel or concrete frame. So that's a real bonus. Okay, it doesn't equate to a 30% saving in the ground. It's probably only about a 5 to 10% saving in the ground, but it's a real saving. Again, something that needs to be taken account of when you're designing with it. And secondary steelwork. I mean, in the UK, we get bogged down with this, but if you can use your CLT panels for your walls and your floors, then you can get away with remove a lot of your secondary steelwork and a lot of these other aspects that come in. Fire, well, some other speakers have touched on it. I mean, it is timber, it does burn. I think we need to appreciate that and we need to work with that. So as a true engineer, we thought it'd be fun to see what happens when it burns. And we know that there is a char layer, a pyrolysis zone, and it's a very predictable rate to which timber would burn at. So we built ourselves a barbecue out of CLT. You could probably only use it maybe 3 or 4 times before it kind of disappears. But we cooked our burgers on there, and they were very nice. We tested the thermal properties of it by putting our hands underneath and seeing if it was hot, which it wasn't, obviously. And then after about an hour, we took the charcoal off, and we let it just carry on. And we wanted to see what would happen. And it carried on smouldering for a bit, but then it went out. It didn't suddenly carry on burning. It didn't suddenly, disintegrate. And for us as engineers, it's a very low-tech, but quite an interesting way of doing things. We wanted to be able to tell our clients, yes, it does burn, it is timber, but it doesn't suddenly disintegrate and everything catch light. And that was really interesting for us and something that we felt our clients can really understand, the non-technical side of things. So we talked a little bit about sequestration. Obviously, I think my map is slightly less green than Katie's was yesterday in terms of where your forest is in the US. But each meter cubed of timber stores about 800 kilograms of CO2. And I thought, in terms of sequestration, that's really interesting, because if we think about each person's contributions to CO2 each year, in the US, that's about 17 tons of CO2. So that's about 21 meters cubed of timber per person. Suddenly you can manage that, you can lock that away in a building and put it up. That can go a long way to helping offset the carbon emissions, and especially for that obviously really wacky idea of putting the carbon underground. So this is a really nice idea, a nice visual way of being able to represent it to people. We've also found that in the UK, the acoustic regulations do sometimes present challenges with CLT, but we've overcome those. We've looked at CLT and looking at how we can manage the noise transfer between walls, how we can manage it between floors as well. And there are ways of detailing it, ways of looking at it. So it shouldn't be a barrier. It should just be as long as you understand it early enough, you can get through it. So I'm going to go through some project examples now of what we've looked at and one of the projects that we've done. You might be thinking, cross-laminated timber, it's a panelized system, so you can build a box, a big box, a small box, a tall box, but it's a box. Well, it does suit rectilinear buildings, but this building which I showed earlier is the Open Academy. This is all made out of flat panels, so they're all flat panels. There's no curved panels in there. There are some flat panels that were curved on site, some of the very thin ones to make balustrades, but it's all made out of flat panels. And I think this is the kind of thing that you need to be telling your clients, your architects, is it doesn't have to limit the ambition of the architecture. You've got you can expose it, you can have glue lams, you can combine it with CLT, you can do lots of various things with it, and it can be a really nice structure. So and this is the BIM model that we created for this structure, and this is it during erection. You can see again, you haven't got a massive facade. There's lots of windows in there. It can be quite open, and typically we had 160 mil thick panels for the walls and the ground floor, working up to 140 to 120, and the floors are about 230 millimeters thick, spanning about 7.5 meters. So they're fairly comparable to other forms of construction. And these are the panels going in. When we actually did this, obviously with the kind of oval nature of the building, you can see the slightly tapered panel going in there. So they actually started off at one point and went all the way around the building and came back to the same point. And we were quite worried that tolerances would have meant that when they got back to the last point, it would be out and it wouldn't really fit properly. Well, in fact, when they got back to that last point, it was only 20 millimeters out, so less than an inch out on the whole way around. Obviously, they had been adjusting as they went round, but still, to be that accurate, I think was really, really impressed us for one of our first CLT projects, that this stuff could be really accurately not only fabricated, but erected. So I heard a little bit about tall timber buildings. These are just some of the projects that we're of. There's obviously much more than this. And one of the projects I'm going to talk about is Dalston Lane, which is the 10-story one there, which is going to be one of the tallest in the world when it's built. Obviously, there are others that are going to be overtaking it. But for me as an engineer, it's really important to start thinking about basics. What is wood? How is it put together? What does it look like? How do the material properties work? Because when you're going tall, that's what you really need to start thinking about. And I'm talking about sort of cross-laminated timber going tall, not glue lam and not hybrid with bits of concrete in there and things like that. I'm talking about pure cross-laminated timber. So for me, it's really important to understand the wood is like a bunch of straws. It's quite squishy in one direction, but very strong in the other direction. And obviously, cross-lamination takes account of that. And this is a microscope image of some wood, where you can really see that kind of that straw-like nature. And it's when you're going tall with timber that's important for me, because you need to think about how that timber crushes and how it moves and how it responds to moisture. And then once you understand that, you can mitigate it. You can engineer it. So the project I'm going to talk a little bit about is Dalston Lane. This is with Andrew Waugh and Waugh Thurston Architects, who we're working on in London, in Hackney. It's a 10-story cross-laminated timber building. It's got a concrete podium at ground floor for it's got a retail use at the ground floor, but above that, it's all cross-laminated timber. One of the main drivers for this was in fact, that underneath the site, we've got two sets of tunnels. We've got high-speed rail under there and cross-rail underneath the building. So we had a weight restriction on the building. So we looked at it in concrete and we looked at it in timber. And we actually worked out that you'd have 15 fewer flats if you did it in concrete rather than timber. So the client has immediately got 15 extra flats because he did it in timber. And, you know, it was a no-brainer for him. In fact, it was so light that we could actually put on in the future an extra 20 flats on top of the structure, and it'd still be okay for the loading restrictions that we needed. So he's got 15 extra flats. He could have an extra 20 flats. So he could potentially have 35 extra flats because he's done it in timber rather than concrete. And that really sold it to the client. Of course, there were other benefits, the speed of erection and everything else, but that lightweight and that nature was really what pushed him to considering the CLT. So this has got 10 stories of CLT, and in this one, we're trying to be as pure to CLT as possible. So we've got a lot of the internal walls stack, they're all load bearing. There's a few step backs, and we've got a little bit of steel in there, probably a handful of steel. And this is going. We're building this with BK structures, and I know they're here today. So you know, this is really pushing the boundaries of what we could do. There's lots of stability aspects we had to consider, and it's a real challenge, but a really exciting one. And this is just the image that was taken probably a couple of months ago, going up on the site. So this is the lower section. The 10-story section is now up to about the 4th floor on site. So it's getting there, and they're starting to clad it. So it should be finished sometime towards the end of the year, start of next year. And as I was mentioning earlier, the technology is already there. We're using off-the-shelf stuff. These are off-the-shelf brackets for our stability loads, for our shear connections, for our screws, for our nails. It's all standard stuff, you know, and that's the key thing for us, is not trying to reinvent it and create lots of bespoke fabricated brackets and things like that. It's about using what's there at the moment and what can be easy and quick to put up on site. So, you know, screws, nails, nail plates, that kind of thing. So I think when it's going to be built, it might be the tallest CLT building in the world. I think it is. I'm sure that it will soon lose that title, which actually I'm quite pleased about, because it means that we are, as an industry, trying to get taller, trying to push the boundaries. So one of the last projects I'm going to talk about is one of the ones that we did quite a lot of building information modelling on. So this is Mayfield Academy. It's a school in London. And on this one, we did quite a lot of work trying to coordinate the mechanical and electrical things, products, and also the architecture and the CLT and the structure, and trying to put it all together. So we obviously worked in collaboration, and as Michael talked about, it is all about collaboration. It's all about getting that early collaboration in. So we worked through it. We created our model, did collaboration with the MEP engineers. We cut all the holes in the model in the CLT panels, made sure they were all coordinated. Obviously, the architecture was made sure everything was coordinated to do with that. And then trying to seamlessly pull this into the fabrication process. So once we took that, we panelized it, and we sent it off to the CLT manufacturer, who would then nest it all on their panels, trying to make it as efficient as possible, trying to put it all together to reduce the wastage, to maximize efficiency. And it worked really well in the end, and it went up, and it was a great project to work on. The last one I'm going to talk about is Blackdale student residences, which I took a group of people around from the US not that long ago. I've only got a couple of slides on this one, but it's 500 student residences, and it was built in the CLT went up in about, I think it was about 12 weeks for all 500 student residences. So, you know, and from starting on site to finishing on site, it's going to take a year for this whole thing to be finished. So it's a really fast program, and it really extols the kind of benefits of CLT production. And here you can see the bathroom pods going in. So there's other prefabrication in there. But it's a really good example of how, when you get a whole design team together and you get the contractor behind it, and everyone really wants to do it, you can do it, and you can do it very quickly. And in fact, in the background there's another 8-story one that we've done in cross-laminated timber. This is a 6-story one. So there's lots of, you know, opportunity there for CLT. So I thought I'd just end on, you know, what are the similarities and what are the differences between, you know, building in the UK and what I perceive as building in the US? Well, I looked at the various different things, you know, the structural analysis, the fire, the erection, and actually, I didn't think there were that many differences. You know, I couldn't see anything that was particularly different that really would be, you know, a showstopper for you guys compared with what we've had in the UK. So, you know, and that quite encouraged me that you can start to use it and start to work through some of those issues that we've had, and we can help you with that. Because, you know, as Michael said, if we can share this knowledge and we can share it, and that's partly why I'm here, to help share that knowledge. So why aren't you using CLT? Well, hopefully you're now thinking about it possibly in a bit more of a positive light than maybe earlier. And what I would say is, unlike this little chap, don't get left behind. Everyone else is thinking about using it. If you can start to use it, then you won't get left behind. Thank you, and hope you enjoyed it.